This simulation looks at the opportunities for traffic management in the Straits of Malacca using Indonesian systems manufactured in Indonesia by RCS. The setup involves the establishment of an aerostat at the top end of the Malacca Straits to surveil a known high risk area, the deployment of two Indonesian naval assets, the Mandau and the Hajar, to provide response options should illegal activity be detected. An additional component of the surveillance activity is a land-based radar system that looks at the southern end of the Malacca Straits and also monitors the high-risk transit area coming out of Singapore. The H3 MilSim simulation can support any number of entities in the simulation to increase the fidelity of the analysis. With respect to individual ships, the radar view associated with any particular vessel is a scalable radar that provides multiple mode views. You can have a surface, anti-surface warfare view. You can have anti-submarine warfare view. You can control the areas where there is a requirement to monitor. And for example, moving from surface warfare to anti-air warfare view, increase the sector coverage. Those sorts of capabilities are inherent in the H3 MilSim simulation. As you move into identify particular areas of interest for training or for analysis, you can overlay information, GIS specific data sets, for example track routes from ships recording. You can work out interdiction times. For example, if you've got a pirate vessel, in this case potentially a drug runner running across the straits, or you have, in the worst case, a pirate speedboat launching an attack against a commercial merchant ship, in this instance a Suez class oil tanker. Suez class max oil tanker. Then you can look at what the options are in terms of support, be that sending a message to the tanker to warn it of attack underway, or provide some other form of assistance. It may be launch of helicopter operation or contact with Malaysian authorities who may have assets available to secure the area. In the simulation, for example, you can vary the speed of the asset to see what would happen if in fact you provided advice and it was able to increase its speed, although on very large merchant ships it's not necessarily a viable action. In terms of establishing what the sensors are on the ship, it's easy to establish communication and radar performance, and then in terms of understanding what search areas can be covered, you'll see that by enabling the surface search sensor ring, the coverage is quite extensive. As you can see from the screen, you're able to put in weapon ranges for anti-air, anti-surface, anti-submarine activity, sensor ranges, and show data links. For example, if you establish communication networks between them, in this instance the communication network is shown as reporting to Singapore Port Ops Control, and there is communication between the Indonesian assets associated with the radars and the aerostat. This simulation enables you to take a range of information, feed it into the simulation to provide training or policy analysis tools to enable you to understand what the risks are associated with travelling along the Straits of Malacca, and also the risks associated with either human intervention, or should there be an accident, should there be some form of exclusion zone applied to an area because of failure of an oil well or rig. You can simulate that sort of activity quite quickly. That concludes simulation for this particular demonstration.